Welcome everyone. In this video, we will look at the dot product of two vectors in two dimensions. First of all, let me write the notation. But before that, let me write the title, dot product. The dot product of two vectors. So as an, let's call it input. As an input, we will have two vectors. And as an output, as the result of the dot product, we will get a scalar quantity. We won't get a vector, we will get a scalar. So we multiply two vectors to get a scalar quantity. And let me show the notation now. The notation is we have vector A and vector B. From the name you can guess, we put a dot in between them to represent their dot product. And by definition, this dot product will be the following. We will take the x component of A and multiply it with the B component of, the x component of B, then add it to the y component of A multiplied by the y component of B. This is by definition equal to this. And let's draw ourselves some diagrams, okay? Let's say that this is x and this is y, as usual. And let's say that this is our A vector and this is our B vector. They have an angle in between them, which we will call theta. This is the angle that our vectors make with each other. So from this diagram, what is AX? Well, when we look at this, we see that all of our vector A is directed in the x direction. So the magnitude of our vector A, and I will just use a capital A for the magnitude of A, and same for B, okay? To keep it short. So all of A is in the x direction. What about B? Well, when we look at B, we see that the adjacent side to the angle theta is on the x-axis. So we simply say B cosine of theta. Plus, let's look at the y component of A. Well, we said that all of the vector is on the x direction, so the y component is just 0. 0 times, well, it doesn't matter what you write next to 0, but let's just write, so by will be b sine of theta, because this is the opposite side. This is the opposite side, and okay. Obviously, this goes to 0, because 0 times any number is 0. So that we have a times b times the cosine of theta. If you want to express it one more time, this is equal to the dot product of vectors A and B gives us a scalar quantity, and the magnitude of that scalar quantity is equal to the magnitude of the first vector, and let's just use the proper notation here. The magnitude of the first vector times the magnitude of the second vector times the cosine of the angle between them. We have just shown this to be true using the definition of dot product. You might be wondering where we would use this. Well, for example, in physics you would use dot product while calculating work, because work is defined as the dot product of force and displacement, distance, which tells you that work is a scalar quantity. This is scalar. And this comes helpful because this tells us, the dot product of two vectors tells us how much of a vector is directed in the direction of another vector. This is why we use it in work, for example, because in work, we want to multiply the distance traveled with the component of force that is pointed across the distance that we have traveled. And you can just do it using this formula that we have just derived. I hope that you found this video helpful. If you have any comments, please write them in the comment section. I hope to see you in another video. Until then, take care.